Hello, 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 hello. Voilà. Okay. I'm Esteban Lorenzano. Thankfully, my name is easier to pronounce in other languages than the one of Guille, but people still does kind of weird accents with it. But okay. But you already know me. I work in Faro since a lot of time. And in fact, people always ask me why I do not present my projects in the show as your projects. Is because my project is Faro. So I will present it here. So I'm going to talk about FFI, as you see, and how can we improve the behavior on it. So, and why that? Because I don't know if you know this quote, but no man is an island. Nobody can live alone by itself. And that's also the case of Smalltalk. Sadly, we are not an island. We need to communicate with the outside world. We need things, and especially Faro needs also to communicate there. So since we are very aware of that, because we need to reduce the amount of effort needed to do this communication, we have been investing in FFI during a lot of years. Since we start, in fact, the project, the Faro project, we first, when we start in 2009, we have the FFI plugin, which everybody knows. I think everybody that programming is quick that, and it was very limited plugin, even if it was doing part of the job. It has no callbacks, and it was absolutely not portable because it was made by hand in the plugin to the VM. That means if you want to introduce a new architecture like ARM, you need to re-implement it from scratch. In 2011, there were around Alien, which was a Elliot Miranda project, and it was a nice project. It implemented callbacks for the first time. And it has a very weird design because it was fun, because you needed to each function that you wanted to implement, it was a separated object, and then it was calling interesting things on that. So Igor implemented Native Boost for us in Faro because we needed something that worked more tight with our needs. Native Boost had a very, very, very nice design that we keep until today. And it was implemented in an SAM JIT, which is doing programming in SAM inside Faro, which has some advantages if you know SAM, which is not the common case. But it has callbacks. It has callbacks too. And it had a drawback by security because you needed to mark the memory that you're using as executable. That was not very cool. And then it was not portable at the point that we needed to move to 64 bits, and Native Boost was 32. And instead of doing the migration of SAM to 64 and re-implement everything again in that, we just created a UFFI, unified FFI means. With first, it used a merge of the FFI plugin and the Alien plugin, but then we moved fast to libFFI, which is a modern implementation that many environments use. It's portable and it's very well tested, and that's what we use today. But we didn't have threading capabilities, and then in 2019, Pablo implemented that for us, and now we have a very nice architecture, which has a beautiful design made by Igor, and different strategies to not blocking the VM when we execute. We do not implement all the possible strategies, but we implement all the ones that we need for now. So I think we have a very, very, very good infrastructure now, but we still have a problem. And for example, last years I have been working in the spec GTK backend, and GTK requires bindings, and the bindings needs to be done, and needs to be done by hand. Because, and that's usually an exploratory work of going to the headers, copying the functions, putting in a class, and see if that works, and that is very, very, very annoying. So when I started to migrate from GTK3 to GTK4, I remember that Mariano, some years ago, did something that it was a parser of a header to get into the image a C library. It had some limitations, more based in the fact that FFI at the time was very limited. But it did the work at the point that is the origin of the lib git 2 bindings that we have. But so I started to work in a new version of that, in fact, which is what I call the Pharo SIG, because I'm very bad with names, but it says what it means. It's a C interface generator. And what is that? The idea is that you want to use a C library, and then you do some magic, and voila, you have it in Pharo. So let's see how this magic is. In fact, we have a library generator object that I call a receipt, because, in fact, I call a receipt because, as I say, I'm very bad with names, and I call half of the things which I work on are called spec, which is a specification, and it was going to be a spec too, but then I thought, no, the spec better not, so I will call it differently. So it's a receipt. And we use libclang to create a translator unit inside Pharo, and with that we pass for a Pharo visitor that uses generators, that uses templates to generate a lot of things in Pharo that we are going to see. So how the code works? I'm going to work with the array-lib bindings that I create. I don't know if you know what it is. It's a very nice, beautiful, small library to do games, to do games in the hard way without any helper. You go and you code in C. So let's see how this looks. Hello? Okay. So let's come here, and it's visible. I made it bigger. So I made it a little bit bigger. Hello, yes. Okay. Well, better? Yeah. Okay. This is a receipt, a small receipt that this is the easiest one that you say you will generate a library, you will use a C library generator for array-lib, which is the library name. You have a prefix because we do not have modes or namespaces yet, so and then you need to prefix your classes with something, and then you are going to import. You give the header, the main header that you import, but sometimes you need more, so you can stack imports there. And the include path, because when you use libclang, libclang needs to find the header, so it's like that, like the -i in the C compiler. And then I say that I use the main thread because since I'm going to do some graphical stuff, I need to execute the event loop in the main thread. Otherwise, I can use the same thread as this is the FFI strategy that the library will do. So let's see how works a little bit. This is a little bit schizophrenic, but okay. How the translator unit looks. If I do this, I can inspect. Oh, I should be able to inspect. That happens because I recompiled the library. Otherwise, I have a backup, don't worry. Backup. backup. But I just generated 5 minutes ago. Well, okay. Okay, things can crash because it's C. You know. So let's go to the backup. What's this? Okay. Backup. Voila. That's better. Like this. So, as I say, a translated unit just going to collect and bring it the information of the libc lang into Pharo. But it's just as you see, there are enums with the values of the enums. There are function declarations. Let's see somewhere more interesting that has some flags. Well, this has two. That has some parameters. The parameters have some references if it is an image. I have everything that I need here. And with this, I execute the generation process. The generation process will generate a structure, different kind of objects that we need. For example, for an enum, it will be an FFI enumeration, but the functions, since they are functions, they need to be somewhere. I install it in the same FFI library object. I don't know if you are, if you can, what? Familiar, yes, thank you. Familiar with FFI, but FFI requires a library, an object that is a library that points to the things. So I do not going to try to generate now because since the translation unit failed, I guess that the other will fail too. But this is what we generate there. So let's take a small overview. The first thing that you see is that in the library, it executes, it creates a typedef library with all the typedef definitions that you have. Why? Because then you use it also inside the functions. The functions are then declared here, doing an algorithm to be the most small talkish possible, which is not always easy. If the library is well designed, this is going to be a nice trip because your functions will be called in a nice way and understandable way, but this is not often the case. In general, C libraries have weird names with weird parameters without meaning. And then we generate also. This is opaque objects that are created as objects itself, and then you have enumerations that we can see here. They are generated with all the values that they take, and the structures, which are more complicated, but they are correctly generated. In fact, this is a good example because if you see here, that says int 4. What is that int 4? That's an array of 4, which the only way that we have in FFI to know that it's an array of 4 is to declare it before. So we detect that kind of stuff and we declare it in the other side. So What else? What else? What else? Well, those are the things. So let's see how the code, the coding on this looks. And I hope this is not going to break my my thing. As you see, after that I took that example from the examples library of Ray, and if I execute it, and this should work, and voila, directly, yeah, you have your first one. And that's automatically generated, zero, nothing done. So let's continue with the presentation now. So that was this. So the receive look, we already see it. Code look, we see it. So some challenges of this. But we use, of course, a derivative of the function parser, but the FFI function parser is not very complete. It has a lot of limitations that, in fact, my idea is that then I'm going to push back this, but first I want to test. So I extended the function parser to include, for example, now it can understand unsigned parameters, unsigned it, this kind of annotated parameters, arrays, structs. It understands the declarations that the old one didn't do it, and what we did before is, okay, this is not supported, and we know that an unsigned int is uint, so we replace it by hand. Now it understands it correctly, and it does it. And then there is a real good problem, which is a libclang problem, or most probably of how I use clang. The fact is that if clang does not understand a type, it does not say, it throws an error saying, I do not understand this. What it gives you? Int. So, which is a huge problem because now I have to disambiguate every int I receive because I don't know if it's a failure or not. Thankfully, I can access to the source code of that declaration because libclang gives you that. But then I need my own tiny C parser to understand what it is. So, and then I say, okay, if instead of int I have a size t, okay, I just replace it and go. But then we will see later that there are other problems because of this, but okay, but for now that. Then there is the other problem that libraries uses some other libraries. And I do not want to bring all the C system into Pharo. I just want to import what I need. For example, from sometimes they publish things like memset, things like that, and then, well, okay. So we declared a way to restrict, to filter what it is. It's just that. And there are some other challenges that I needed to solve there. How it looks, you already see that. So I have a couple of examples more. This is something for Sabine I made, which is very easy. And the fact is that since we cannot implement by hand everything, it's nice to have a way to access to this, so to the libraries. Sabine needed to validate XMLs, so I took the XML library, I parsed it, and I just quickly had a solution for that, and I just wanted to show it because I think it's cool. What? Do not touch the cable. So this is I imported with this recipe that you see there that has a little bit of more detail, but I will not enter into in details there. I generate the libxml, which are, as you can see, which are that kind of line of codes, all the generated. Imagine doing that by hand. But with that, I can easily code this method here. As you can see, it's not so fun that the Raylib because XML is old and ugly, but you can do it, and you can handle that, and you can validate, for example, this ship order that is there, that is throwing an error, because I put an error expressing, so I can show that it is doing. If you pass the XSD to this file, and will file say that it's in the line 11, but it is C, so it is in line 12. In fact, there is an error that you can see here. So I save this, and now if I execute this, I should not have a list of errors. Exactly. So that works. And the third example that I have to show, it's OpenSSL. We can now have OpenSSL complete functioning inside Pharo without needing to actually map the library. Just we have it. And I have a nice demo that will encode. Have a SUG. Mariano, don't look like that, because you distract me. Okay, it does not support Unicode, but okay. So I have this, which gives you a byte array with all, and if I decrypt this, I will have that. So it works. Okay. So, OpenSSL. But then there is another problem. Many libraries are made in C++. And there is no standard ABI, and so, and it's painful to do that, so we should do something better. So that seems easy, no? Okay, we do some magic. Okay, the magic is a little bit more complicated. So, thing is that we need to take the same information to generate a bindings file that is going to be compiled, and that will be the library that we use, and that's how it is done, and that's how everybody does it, because it's the only way to actually talk with that. So we generate that. And the C generator and that has certain difficulties, like this is C++, of course. In C++, structs are classes too, and classes are structs too, and you need to understand that. And all of them can be anonymous, and they have namespaces and aliases, which is like a type def, but with steroids. And then we have templates, which are template class, template function, templates everything, every day. And why this exists? Why? But okay, but we need to do it. The templates are particularly complicated. You know why? Because libclang has the bad habit to respond you int when it should be that. So you need to go there, take the string, and parse the string by yourself, and good luck with that. And I spend a lot of time fixing that. And then there is also the standard library, which is HUE, and it's everything there. And then we need to be aware on how to import that. So, but I succeed. Yay! In this example, this is a working process. But you know what libnoise is? But you know when I am bored and I start to procrastinate, I tend to work with procedural generation stuff and that, because that's fun. And the last in Pharo days, I show you a procedural galaxy, and then I was saying, right, let's generate a planet. And well, the noise function that we had in Pharo was very limited. I needed more, and in fact that was the origin of this project. So let's see this. But let's do it quick, because otherwise Sebastian will kill me. Example, another recipe. This is how you create libnoise with C++. And the fun thing here is that you have two libraries there. You have libnoise and noise utils, that is a library that they give you to generate bitmaps and data, and I'm going to use for example. No? And I'm going to do it fast because, as I say, Sebastian is looking at me like with killer eyes. Now, say, well, you do more or less the same. The difference now is that you give the library that you will use. And in the second one, which is interesting, I do not want to map because noise utils uses libnoise. But I do not want to remap in noise utils libnoise, so I pass the namespaces that I generate so he does not repeat the process. And then, as I say, I will not try it because I don't know why it crashed, and it can be for whatever thing, but it will generate something like this. This is the library. I say each namespace is generated in a tag. And what is fun is that I can reproduce also the hierarchy, the class hierarchy, with the correct calls. And each call will be calling this, which uses a convention that GTK started, which is kind of objective way of programming things. And that's my generated function. In the C side of things, this generated this. Let's see, like this. This generated a makefile, so you can build your library. It generated a bindings file, a header file with everything that you need. Each class is separated, and it generated also a C++ file, which has several things, C file, sorry, which all the mappings that you do for going and back. So it's kind of cool. And then you can do things like this. Voila, we have a Earth-like generated map. But of course, this is just the starting part, because then the idea is to integrate that into your applications. And since I do procedural generation for that, for example, I have also this, which is using spec-GTK plus Alexandria, which is the new backend of Block. I do not use Block because at the moment it was not ready when I did this example. What is? And voila. And we have a map. What's that? I don't know why is that. File item. And you know, I can update it, giving it another seed, and I have different maps, and I can just start watching my map and that works, and that's how games start, for example. And I'm sure that it can be used for more interesting things than just gaming, but okay. And well, okay, we saw this. That's the code, and okay, but you have the example there. Of course, you will not going to look at that. Well, remarks, but there is some problems anyway. First, that not all C++ libraries are designed to be used outside C++. For example, at the moment, we cannot map white box libraries, the ones that requires you to extend a class in C++, because we cannot extend classes of C++ in Pharo yet, and I don't know if we are going to implement it anyway. Something that I already said, we can, good C libraries have a lot of information. In fact, in libc noise, I didn't show it, but we imported even the class comments and method comments, which it's very good to have, because then you have everything you need with in comments appropriately. So you can have very nice documentation even inside. But truth is, most libraries are not designed like that. So, but you can, once you generate it, it does not recreate from scratch. It just overrides what is there if you regenerate. So you can use then you can use the same libraries to start constructing your abstractions and enhance that, but then you have a starting point of there. Okay, so the status is that I have 60% of test coverage. I would like to arrive at least to 80%, but we are more or less okay. C is working, but variadic support is missing because I didn't implement it. It's like 10 minutes to implement, but I didn't do it. The variadic support, in fact, is just letting the user, ask the user to declare which functions, with variadic functions want to use it, and we declare it like that. We use, it's not, and C++ is on the way. I think simple libraries parse correctly. More complex libraries, especially the ones that use weird parts of the standard libraries, are not. And documentation, well, yeah, okay, one day will come. I don't even have a README in that. So he says to end with the end of the poem that started this. It's like this is a nicer way of saying of the same that GFK say: ask not what your country can do for you, ask what you can do for your country. What you can do for me, for this project. For this project, it will be always a beta because there will be always cases that we cannot cover. I cannot, in a lifespan, it's impossible to map everything that C++ has to offer. So we are going to, in abstract, so we are going to do it case by case. Hopefully that case improves the next one and eventually we will be there. But it's going to be a beta for a long time. So you can contribute by parsing libraries and publishes them. For example, Pharo RayLib is published, Pharo libnoise is published, Pharo OpenSSL is published in GitHub, and Pharo libxml they are all published already, which is already an improvement in the Pharo ecosystem. And you can help to improve the generators if you feel like, and you can ask for your library bindings to be generated, and we will do our best. So thank you very much. That's it.
You said you don't support variadict in C, parsing C headers, the functions with the variable number of arguments.
Yeah, this is because Pharo Smalltalk requires a keyword message to be executed, and keywords are not variadic. So what we do is we ask the user to add a list in the recipe. They can add a list, and we just generate that for them. And that's what we can implement in 10 minutes. I just didn't do it because I was more busy preparing the slides.
I'm wondering how you parsed OpenSSL things. I know OpenSSL has some functions.
We are ignoring them for now. I'm marking them, and I'm ignoring them.
You just pass.
Yes, I just report. There are variadics here, but I cannot do anything because I don't know what is going to be used for the users. Imagine you want to map printf. That's just not possible. So, and then we could also add a function, a slow function that will not be JIT compiled because that receives an array with the types and with type, or a dictionary with type and things, and then it executes the variadic. That's very easy to implement with UFFI. But for the moment, I didn't choose that because I think it's ugly. So I prefer to ask the users to say, okay, you tell me which ones you're going to use.
So when you parse the header, you just ignore it.
For now, yes.
Okay.
Yes.
It doesn't generate an error; it just skips it.
No, it just does not generate. It skips it, it throws a line saying, hey, warning, this is not generated. And that's all.
Okay, thank you.
Last time we talked together,
yeah,
we talked about Faust.
Yeah.
And I remember you were telling me that was difficult. What was the problem then?
Yeah, the problem is that Faust is not one of those libraries that are nicely designed. The problem is that Faust uses a global structure to store everything, and it's a structure that in fact is a class, and it has a lot of weird stuff. And then I tried, like, it was 3 months ago, and honestly I didn't have time to retry. Maybe now it's passing or it's missing. Not far. One thing that I didn't say is that for public properties of a class, what we do is generate a setter and getter mechanism. Since we have an intermediary, we can do that without a problem. So, but we need to try that again. That's the thing.
It's maybe a naive question from my behalf, but well, I've seen some parsers, etc., for several languages. I think C++ is one of them within the ecosystem from Glamour Toolkit, and I think Moose also. So if I understand correctly, you built custom parsers for this? Or?
No, not at all. Yeah, but there are some things that can be extended by a parser in the future, but especially with the detection. There is this thing also with templates. I didn't say it, but what happens is that we detect in the headers all the templates and all the possible usages that are in the header, and then I declare an abstract class which is the template base, and then subclasses which each specialization of the templates. So you can access, and also as the variadics you can declare your own ones if you want. For parsing that, the things that are inside the templates, in the future maybe it will be cool to have something more parsish than what I have right now. What I do is just substrings and detect the parts, because the fact is that you detect the part and then you have to search for it in the tree that you in the IST. It's kind of an IST that I have, and you have to search for it. In the future we can use, but for now we don't use any parser because we use libclang. My main idea is to re-ask clang for retranslate that but clang is something made for C++ people, so it's as incomprehensible as C++ itself. So it's hard to get it to the point. But I prefer not to do a parser myself or to use SMAC, because it's just adding another dependency just for that. But one thing is that this is another thing is this is conceived as a tool. It does not generate any extra dependencies. Once you generate your library is independent of the tool. You don't need. In fact, my whole idea is to have an application with this so people can generate with their receipts their libraries and then just forget about it. But so we could add a dependency in the case of need, but I prefer not to if I can avoid it. Okay, no questions. Thank you very much.